Okay, so in this video, we're going to talk about solving quadratic equations by taking square roots. Now, I'm going to use this method when I encounter a problem and I have a variable raised to the second power and I do not see the same variable again with a different exponent. And so all of these problems we're going to do out today, you're going to see just a variable raised to the second power, and we're going to work through the process of solving it. And so here in the first two questions, both of the squared terms are already isolated. If they were not, that would be my first move. Now, I want to solve for n. So to undo n to the second power, I would take the square root of both sides. Now, the square root of 81 is 9. The square root of n squared is the absolute value of n, which means my next move would be to solve for n. So the absolute value of what two numbers makes positive 9? That means n could be negative 9 or n could be positive 9. And here's my answers. Now, what we actually did by solving this equation, let me pull up Desmos here and we'll look at what we accomplished. And so if I graph my first problem here, and so I go y equals, instead of n, I'm using x squared. I have y equals x squared, which is the left-hand side, and y equals 81, which is the right-hand side. And I'm looking for the intersection in the two curves. So I have to zoom out a little bit so I can see 81 on the y-axis. And I'm looking for where they intersect. And so I look at the points of intersection, and I see they intersect with one x value of negative 9, which we got, and they intersect again with a x value of positive 9, which we have as well. All right, so we're going to move on to number 2. R squared equals 25. Now, I know that we can sit there and think of a number that we can square and make 25, which is 5. But we're trying to practice the algebraic technique in solving, because as you progress forward into higher level math, it becomes important that we do this correctly and we show our steps. So I would need to take the square root of r squared, and I would need to take the square root of 25, because what I do to one side in an equation, I have to do to the other side. And the square root of 25 is positive 5. The square root of r to the second power makes the absolute value of r. And here we would get that the absolute value of two numbers makes positive 5. Both negative 5 and positive 5 would be my answers. And we could check this very quickly on Desmos. So let me slide my window back over and say, all right, here, if I was graphing y equals x squared, and I graphed y equals 25, and I'm looking here on the right-hand side, I would go find the 2 points of intersections, and my answers are going to be the input values or the x values when I solve by graphing. All right, moving on to another one. So number 3 here. So number 3, I cannot just jump right into taking the square root because I have 2 times n squared. I need to isolate the squared term. So my first move in this problem here is going to be to get n all by itself. So I would have to divide both sides by 2. That would give me n to the second power equals 36. Now that n squared is isolated, now I can go through and I can take the square root of both sides. So the square, I would have to take the square root of n squared, and I would take the square root of 36. Well, the square root of 36 is positive 6. The square root of n squared is the absolute value of n, which means that I have 2 numbers I could take the absolute value of to make positive 6. N could be negative 6, or n could be positive 6. My 2 answers. And we can check that pretty quickly here and see the intersection with Desmos. So I graph my two equations, y equals 2x squared and y equals 72. And I'm looking for the point of intersection. So I'm going to zoom, see the intersection of the two curves, touch where they cross, and they cross at x equals -6 and x equals +6. All right, moving on here to 4. So here in number 4, I have a similar scenario. The x squared is not isolated. So I cannot take the square root to remove the exponent of 2 until I have that term isolated. So I would need to move the 8 to the other side. And so I'm going to subtract 8 from both sides here. And that's going to give me x to the second power is equal to -12. And then we would go through and say, all right, well, in the other 3 examples, our next move was to take the square root of both sides. And we run into an issue. And the issue is going to be the right-hand side. We're trying to take the square root of -12. And we can only apply the square root to values that are 0 and greater. So because I cannot apply the square root to a negative number and get a real number answer, now as you progress forward to Algebra 2 and beyond, we have techniques to take the square roots of negative numbers or just imaginary or complex numbers. But we're looking for real number solutions. So because I can't take the square root of a negative value and be real, this here would be no solution. Now, this would be an interesting one to look at graphically and say, well, why is there no solution to this problem? So I'm going to graph the equation y equals x squared plus 8 and graph the equation y equals -4. All right, so turn my graphs on and I look. We're looking over here on the right-hand side. I see the parabola in purple. And then the line y equals -4 is down beneath the x-axis. They never touch each other. And so if my two equations, and I'm solving a system graphically, basically that's what you're doing every time you solve an equation. If they do not intersect one another, there are no real answers. So that's why there's no solution, both graphically and algebraically. All right, moving on to 5. Now we have 8x squared minus 7 equals 65. And I need to isolate the x squared term. Well, the first thing, when you're trying to solve equations, you do order of operations in reverse. So I don't want to just jump right in and divide by the 8. I want to move any addition or subtraction. So I want to move the minus 7. So I'm going to add 7 to both sides. I do that, I get 8x squared equals 72. Now I would divide by 8 so I can get x squared all by itself. I divide both sides by 8. I have x squared is equal to 9. Now x squared is isolated. Now we can take the square root of both sides. So the square root of x squared would equal the square root of 9. And the square root of 9 is 3. And the square root of x squared is the absolute value of x, which means we have two possible values for x that we could take the absolute value of and make positive 3. X could be -3, or x could be positive 3. All right, we'll look at this one too graphically on Desmos, and we should see that if we graph the two expressions, so y equals 8x squared minus 7 and y equals 65. And I'm going to have to zoom a little bit here. All right, and I can see that they indeed intersect each other. Once at -3 and once at positive 3. All right, last example here. 1 plus 64n squared equals 2. And so we would start to isolate the n squared. I got to move the addition or subtraction first. I'm going to move the 1 to the other side. I'm going to subtract the 1. That's going to give me 64n squared is equal to 1. Now, to isolate the n to the second power, I'm going to divide by 64. Which is going to give me n to the second power is equal to 1 over 64. Now, my process from here does not change. I still would want to take the square root of both sides. And so, I'll give myself a little bit more room. I'm going to take the square root of both sides. So the square root of n squared is equal to the square root of 1 over 64. Which, the square root of n squared is the absolute value of n. The square root of 1 over 64. Okay? If I'm taking the squared root of a fraction, I could treat this as taking the square root of the numerator and the squared root of the denominator separately. So the squared root of 1/64 is equal to the square root of 1 divided by the square root of 64, which is the square root of 1 is 1, the square root of 64 is 8. So the absolute value of n has to equal 1/8. Well, there's two numbers whose absolute value equals 1/8. That would be negative 1/8 and positive 1/8. And let's see this graphically with Desmos. So I want to graph here number 6. So y equals 1 plus 64x squared and y equals 2. Now I'm going to have to zoom in here. I already know that. So let me zoom in. I gotta make sure I see the 2. All right, so graph number 6. And I look and I see that, yes, they do cross each other. And they cross each other twice. And I'm going to find their intersection points. So negative 0.125 and